It is highly likely that the metal flue and gas piping are acting as a lightning rod. Lightning seeks the path of least resistance to the ground, and metal components in the chimney and gas piping provide a direct path. To mitigate the risk of lightning strikes and electrical damage, proper electrical bonding is essential. Firstly, bond the metal chimney flue to the electrical grounding system. This should be done using a copper bonding strap connected to the grounding rods. Secondly, bond the metal gas piping to the electrical grounding system. Connect the gas pipe to the grounding rods using an approved grounding clamp or connector. Thirdly, bond the propane tank to the electrical grounding system. Install a ground rod near the tank and bond it to the tank using a copper grounding wire. Fourthly, consider additional grounding electrodes. If possible, install additional ground rods to improve the overall grounding of the system. Only qualified electricians should perform the electrical bonding and any other electrical work. If you hear electrical arcing sounds, leave the house immediately and call the fire department. Have the electrical system inspected by a qualified electrician after a lightning strike. Install surge protectors on all valuable electronics and appliances. Consider installing a lightning protection system for the house. Keep trees and branches trimmed away from the chimney and roof to reduce the risk of lightning strikes. Let's delve into the details of electrical bonding and grounding systems. Electrical bonding is the process of connecting metallic parts of a structure or system to create an electrically conductive path that ensures electrical continuity and the capacity to safely conduct any fault current likely to be imposed. Grounding, on the other hand, connects the electrical system to the earth, providing a low impedance path for fault currents to flow, which facilitates the operation of overcurrent protective devices like circuit breakers and fuses. When lightning strikes, it seeks the path of least resistance to the ground. If a metal chimney flue or gas piping is not properly bonded and grounded, it can become that path, leading to dangerous electrical surges and potential fires. The primary purpose of bonding the metal chimney flue to the electrical grounding system is to create an equal potential between the flue and other grounded metal parts. This reduces the risk of electrical arcing or sparking that can occur when lightning strikes. To accomplish this, a copper bonding strap, which is a flat, wide conductor, is typically used to connect the metal flue to the grounding electrode system. The grounding electrode system usually consists of one or more ground rods driven into the earth. The copper bonding strap should be securely fastened to the metal flue using appropriate connectors, ensuring a reliable electrical connection. Similarly, bonding the metal gas piping to the electrical grounding system is crucial for safety. Gas piping can also provide a path for lightning currents, potentially causing ignition of gas or damage to appliances connected to the piping. To bond the gas piping, an approved grounding clamp or connector is used to connect the piping to the grounding electrode system. It is essential to ensure that the connection is made on the supply side of any gas meters or regulators. The propane tank, being a large metallic object, also needs to be bonded to the electrical grounding system. This is typically achieved by installing a ground rod near the tank and bonding it to the tank using a copper grounding wire. The grounding wire should be securely attached to the tank using a suitable connector. In addition to bonding these specific components, it is also beneficial to consider adding additional grounding electrodes to improve the overall grounding of the system. This can be achieved by driving additional ground rods into the earth at various locations around the house and connecting them to the existing grounding electrode system. The spacing between ground rods should be at least equal to the length of the ground rod. The National Electrical Code, or NEC, provides detailed requirements for grounding and bonding electrical systems. It is important to consult the NEC and follow its guidelines when designing and installing grounding and bonding systems. Some key sections of the NEC that are relevant to this topic include Article 250, which covers grounding and bonding in general, and Article 800, which covers communications systems. When performing electrical bonding and grounding work, it is essential to follow all safety precautions to prevent electrical shock or other hazards. Always disconnect the power to the circuit before working on any electrical components. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. If you are not comfortable working with electricity, it is best to hire a qualified electrician to perform the work. Surge protectors are devices that protect electronic equipment from voltage spikes and surges. They work by diverting excess voltage away from the equipment and safely dissipating it. Surge protectors are available in various forms, including whole-house surge protectors that are installed at the main electrical panel and plug-in surge protectors that can be used to protect individual appliances. Installing surge protectors on valuable electronics and appliances can help prevent damage from lightning strikes or other electrical surges. A lightning protection system is a comprehensive system designed to protect a structure from lightning strikes. It typically consists of air terminals, also known as lightning rods, which are installed on the roof of the structure. These air terminals are connected to a network of conductors that route the lightning current safely to the ground. Lightning protection systems are typically installed by specialized contractors who are trained in their design and installation. Keeping trees and branches trimmed away from the chimney and roof can help reduce the risk of lightning strikes. Trees and branches can provide a path for lightning to strike the structure, potentially causing damage or fire. Regular tree trimming can help minimize this risk. The principles of grounding and bonding are based on fundamental electrical concepts. Grounding provides a low impedance path for fault currents to flow back to the source, allowing overcurrent protective devices to operate and clear the fault. Bonding ensures that all metallic parts of a system are at the same potential, reducing the risk of electric shock. The effectiveness of a grounding and bonding system depends on several factors, including the size and type of conductors used, the quality of the connections, and the soil conditions. Proper installation and maintenance are essential to ensure that the system functions correctly. The NEC specifies minimum requirements for grounding and bonding based on the size of the electrical service and the type of system. These requirements are designed to provide a reasonable level of safety. However, in some cases, it may be necessary to exceed these minimum requirements to provide adequate protection. For example, in areas with high lightning activity, it may be beneficial to install additional ground rods or use larger grounding conductors. Regular inspections of the grounding and bonding system are important to ensure that it is in good condition. Look for signs of corrosion, loose connections, or damaged conductors. Any problem should be corrected promptly to maintain the effectiveness of the system. In addition to protecting against lightning strikes, grounding and bonding also help to protect against other electrical hazards, such as ground faults. A ground fault occurs when a live wire comes into contact with a grounded surface. This can create a dangerous shock hazard. A properly installed grounding and bonding system will provide a low impedance path for the fault current to flow, allowing the circuit breaker or fuse to trip and de-energize the circuit. The size of the grounding conductor is determined by the size of the overcurrent protective device protecting the circuit. The NEC provides tables that specify the minimum size of the grounding conductor base and the ampacity of the overcurrent device. The grounding conductor should be made of copper or other approved conductive material. The grounding electrode conductor connects the grounding electrode to the electrical system. The grounding electrode is a metal rod, pipe, or plate that is buried in the earth and provides a connection to ground. The grounding electrode conductor should be sized according to the NEC and should be securely connected to both the grounding electrode and the electrical system. The location of the grounding electrode is important. It should be located as close as practical to the electrical service entrance. The grounding electrode should be driven into the earth to a depth of at least 8 feet, or according to local codes. The resistance of the grounding electrode is also important. The NEC requires that the resistance to ground of the grounding electrode not exceed 25 ohms. If the resistance exceeds 25 ohms, additional grounding electrodes may be required. The use of ground rods as the only grounding electrode might not be sufficient, especially in areas with poor soil conductivity. In such cases, it may be necessary to supplement the ground rods with other grounding electrodes, such as a ground ring or a concrete-encased electrode. A ground ring is a continuous loop of bare copper conductor that is buried around the perimeter of the building. A concrete-encased electrode, also known as a U for ground, is a steel reinforcing bar that is encased in concrete. Both of these grounding electrodes provide a larger contact area with the earth, resulting in a lower resistance to ground. In addition to grounding and bonding, surge protection is another important aspect of electrical safety. Surge protectors are designed to protect electronic equipment from voltage spikes and surges. Voltage spikes can be caused by lightning strikes, power outages, or other electrical disturbances. Surge protectors work by diverting excess voltage away from the equipment and safely dissipating it. There are two main types of surge protectors: whole house surge protectors and point of view surge protectors. Whole house surge protectors are installed at the main electrical panel and provide protection for the entire electrical system. Point of view surge protectors are plugged into individual outlets and provide protection for the equipment plugged into that outlet. It is recommended to use both whole house and point of view surge protectors to provide comprehensive surge protection. When selecting surge protectors, it is important to consider the surge current rating. The surge current rating is the maximum amount of current that the surge protector can safely divert. A higher surge current rating indicates better protection. It is also important to choose surge protectors that are listed by a recognized testing laboratory, such as Underwriters Laboratories or UL. UL-listed surge protectors have been tested to meet safety standards. In addition to installing surge protectors, it is also important to protect electronic equipment from power outages. Power outages can damage electronic equipment due to the sudden loss of power. Uninterruptible power supplies, or UPSs, can provide backup power during a power outage. UPS typically use batteries to provide power to the equipment. When the power goes out, the UPS automatically switches to battery power, allowing the equipment to continue running for a limited time. UPS are available in various sizes and power ratings. The size of the UPS should be chosen based on the power requirements of the equipment being protected. It is also important to choose a UPS that has a sufficient battery capacity to provide backup power for an adequate amount of time. Regular maintenance of electrical systems is essential to ensure safety and prevent problems. Electrical systems should be inspected regularly by a qualified electrician. The electrician should check for any signs of damage, such as frayed wires, loose connections, or corroded components. Any problems should be corrected promptly. It is also important to keep electrical panels and equipment clean and free of dust and debris. Dust and debris can accumulate on electrical components and cause them to overheat. Overheating can lead to electrical fires or equipment failure. When working on electrical systems, it is important to follow all safety precautions. Always disconnect the power to the circuit before working on any electrical components. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. If you are not comfortable working with electricity, it is best to hire a qualified electrician to perform the work. The information provided is intended for general guidance only and should not be considered as a substitute for professional advice from a qualified electrician. Electrical work can be dangerous, and it is important to take all necessary precautions to ensure safety. By following the recommendations outlined, you can help to protect against lightning strikes and other electrical hazards. Furthermore, understanding the specifics of a 400 amp 120/240 volt single-phase system is crucial in this context. A 400 amp service implies a significant electrical load capacity common in larger homes or properties with substantial electrical demands. In such a system, the grounding and bonding become even more critical due to the potential for higher fault currents. The fact that the system uses two ground rods as the sole grounding electrode raises concerns, especially given the absence of a metallic water pipe for grounding. The NEC generally favors using a metallic water pipe as a primary grounding electrode, supplemented by other electrodes like ground rods. Since there is no metallic water pipe, the reliance on just two ground rods necessitates a careful evaluation of their effectiveness. The NEC mandates that if a single ground rod is used, its resistance to ground should not exceed 25 ohms. If it does, a second ground rod is required. However, even with 2 ground rods, achieving a sufficiently low resistance to ground can be challenging, particularly in areas with poor soil conductivity. The absence of bonding between the bottled gas tank and the metallic plumb into the electrical system further compounds the risks. This lack of bonding creates a potential difference between the gas system and the electrical system, increasing the likelihood of arcing or sparking in the event of a lightning strike or electrical fault. To address these issues, several steps are recommended. Firstly, a thorough inspection of the existing grounding electrode system is essential. This involves measuring the resistance to ground of the ground rods to ensure compliance with the NEC requirements. If the resistance exceeds 25 ohms, additional ground rods should be installed to reduce the overall resistance. Secondly, the bottled gas tank and metallic plumbing must be properly bonded to the electrical grounding system. This can be achieved by installing a ground rod near the tank and connecting it to the tank and the gas piping using appropriate grounding clamps and conductors. The size of the grounding conductors should be determined based on the size of the electrical service, as specified in the NEC. Thirdly, it is advisable to consider installing a whole house surge protector at the main electrical panel. This will provide protection against voltage spikes and surges that can damage electronic equipment and appliances. The surge protector should be sized appropriately for the 400 amp service. Fourthly, regular inspections and maintenance of the electrical system are crucial. This includes checking for loose connections, corroded components, and damaged wiring. Any problem should be addressed promptly by a qualified electrician. It is important to note that electrical work can be dangerous, and it should only be performed by qualified professionals. Attempting to perform electrical work without the necessary knowledge and experience can result in serious injury or death. By taking these steps, it is possible to mitigate the risks associated with lightning strikes and electrical faults, and to ensure the safety of people and property. Always consult with a licensed electrician to ensure compliance with local codes and regulations.